Okay. Let's see. We got some more people here. Good. Talk to me. Who's had an interesting job? Anyone? Come on, guys, talk to me. Just make something up.
I work in a kitchen,
Who does?
a
Is it
retirement
Brian?
home.
Brian, wait a
Hello.
minute. Are you serious, Brian?
Oh,
Really?
trying to put me down.
That's what I did when I was in school.
Oh, yeah.
I absolutely hated it.
Oh.
I've been doing it for 6 years.
Really?
Yeah.
And times have changed, okay? Clearly. I guarantee they've changed. Where's the retirement home?
I work at the Abbeywood. It's on Abbey Road in Elyria.
I've heard of that.
Yeah.
Is that kind of across the street from like those street names that are named after universities?
Yes.
My daughter used to live on Case Avenue. My
Yep.
daughter and son-in-law. So are you a cook there?
Yeah, I started as a server, like
Sure.
in high school, and I'm a cook now.
So Brian, I know I'm pretty sure your kitchen doesn't run this way, but we're gonna have to pretend that it
We're gonna
does.
pretend.
Yeah. So Brian has to cook or prepare, I guess, right? Dinners that are in order, right? Or dinners. Let's just say dinners. And I am modifying my example to fit. Okay. From what do they call the so like
The
in a
AA
regular
menu.
restaurant? What's that?
The AA menu, always available.
Okay.
Is that where you're going?
I have no idea where I'm going. I'm trying to fit the. You're going to grab some orders that need to be prepared, and one are going to be one type, and another going to be another type. So, one is. Do you have a like? Are some of the dinners that you prepare? Are some of them like mainly cold things?
Our appetizers are cold.
Okay,
The way we do it is we have a soup of the day, and then we have two like main entrees that are already made that can just be plated. And then we have an AA menu, which are like quick fire, like burgers, grilled cheese, that kind of
So you got two entrees, right?
Yeah.
Okay. All right. Prepared dinners from a one of two possible entrees. That's actually the way it was way back in the day when I was in the kitchen. So like you could order one of two entrees, and they had a 20. I think she had a 28-day menu.
Yeah, 4 weeks.
In other words, it repeated every 28 days. So like on Wednesday you could have like for dinner you could have pepper chicken or something else. I don't remember what.
We have 4 6-week rotations. So for the spring it cycles twice, and then the summer it'll be 2 cycles.
So, there are a total of what are the entrees? Just throw something out there, Brian.
Yesterday we had stroganoff or country ham and beans.
That actually sounds really good.
I made the ham and beans and we sold out. And we usually don't sell any of it.
So there are 10 stroganoff orders on the carousel or whatever. It's actually got what you call it. Do the waitresses or servers?
We don't have one of those, but we would if we had one.
Okay, so there's 10 stroganoff and 15. You said ham?
Ham and bean. It's like a stew.
Okay, stew. Okay, so there's 15. And since Brian has been there six years, right?
Yep.
So you can do whatever you want. Okay? All right.
More than you realize.
Yeah. So Brian takes 6. Do you call them orders or tickets or something like that? What do you call them?
We use orders as the terminology.
Orders. At random. Okay. So there's this carousel or something for Brian to pick from. Okay. If Brian was conscientious, which clearly he is not, he would take them in the order that they were submitted, right?
Yeah.
In other words, if you got some old lady that's been waiting for like 3 hours for her stroganoff, that one would be done first. But Brian's been there a while, so he really doesn't care, So he's just going to grab 6 orders and take care of them. Okay? Everybody got the situation here? Yes, no? What's the probability that of the 6, how many are stew? Give me a number.
3.
3 of the 6 are stew. Okay. Are we ready to roll? Are we ready to solve this thing? I'm going to sit down because I can't bend. And I can write at the bottom. I can write on the bottom of the board with some degree of legibility. So, guys, do you see what's going on? The servers come in and they deliver a total of 15 orders for the cooks to prepare, right? For the dinners. And we know in advance somehow that 10 of them are stroganoff and 15 are stew. Brian, are you the only cook, Brian?
No.
So you would not be the only person preparing these dishes?
We actually have 2 kitchens, so it gets a little...
Oh. So there'd be a helper in the other kitchen?
Yeah.
Okay. So Brian, clearly, Brian only wants to do what? Basically a quarter of the work, right?
That sounds great.
If Brian's only taking 6 out of 25, think about it. The other dude's got to do 19. So anyway. All right. what's the probability that 3 of the 6 that Brian grabs and prepares are for the ham and bean stew? That actually sounds really good right now. So does stroganoff. I'd have a rough time picking. Okay. So, what do you think, guys? One of the ways, one of the principles of probability, the probability of an event A, probability that the event A occurs. How about if we phrase it that way? Equals the number of ways for A to occur divided by the number of possible ways for the experiment. Okay, we're going to talk about this now, so you can understand what's going on. What if we're flipping a coin? That's the experiment. Just once, and the event A is that the coin ends up being heads. Okay, so the number of ways for a heads to, if it's a fair coin, the number of ways for a heads to occur is 1, correct?
Right.
The number of possible ways, possible outcomes is 2, right? It could be heads, it could be tails, right? And this is for fair events. I should have said that up front. So the probability for a certain outcome to occur, that it has the same probability as any other outcome. Okay, so if we flip a coin, and it's fair, there's one way for it to come up heads, but there's 2 possible ways total, right? So the probability of a heads is 1 out of 2, which matches what we would think. Yes, no?
Yeah.
What if it's a fair die? And the event A is that we roll a 3. Well, there's one way for a 3 to occur, but there's 6 possible ways, 6 possible outcomes, right? So the probability of 3 is 1 out of 6. What if the event A is that we roll an even number instead of just a 3? Well, how many ways are there to roll an even number out of a 6-sided die?
3.
3. How many total ways to roll a 6-sided die? Or outcomes from that roll? There's 6, so it's 3 out of 6. So the probability of an even number is 3 out of 6, which is 1/2. What if again, 6-sided die, what if the event A is that we roll a number that is greater than 4? Well, how many ways are there to roll on a 6-sided die? How many ways are there to roll a number that is greater than 4?
2.
2. 5 and 6, right? You don't include the 4 because it says greater than. Well, again, there's 2 ways for A to occur. Number of possible ways is 6, so it's 2 out of 6, which is 1/3. You guys see what's going on here?
Yeah.
When it comes to being fair, this isn't a bad way to look at it. Okay. And this is the approach we're going to take to solve this problem. Are you ready?
Yes.
So, the event A is the event that Brian chooses 3 of the 6 that are stew. That's the event A. How many ways are there to do it? Well, there's 15 total stew, right?
Mm-hmm.
Does the order matter?
No.
Right? We already established that. Brian doesn't care of any order that happens in his kitchen. He doesn't care if somebody's been waiting for 3 hours, right?
Right.
So we're looking at combinations, right? So the number of ways to choose three stew, which also implies automatically that 3 are stroganoff. Yes, no? Yes, no?
Mm-hmm.
So do you see that it's the oh, I forgot to show you something. I'm sorry. You guys probably, if you've had permutations and combinations before, there's a good chance you didn't represent combinations by this notation. You probably wrote this. Yes, no? With the parentheses. Is this familiar to anyone?
No.
You've done it this way? You've seen this way? Wow. That's probably the first class I've ever had that nobody's had this notation. Most of the time, students have never seen this. So either way is correct. Okay. So do you see that there's 15 stew orders for stew? Brian's going to grab 3 of them, right? But that also means that he has to grab at the same time 3 orders for stroganoff. And there's 10 total. So the number of ways for Brian to choose 3 stew and 3 stroganoff is combination of 15 things taken 3 at a time times the combination of 10 things taken 3 at a time. Okay? All right? And we use the multiplicative rule because there's this many ways to do the first operation, this many ways to do the second operation. Okay? How many ways to choose 6 orders from 25? So, like, are the people in your retirement home, are they somewhat able to take care of themselves?
um
Or do they all have AIDS or something like that?
So half of our building is independent living, and they're technically supposed to be completely self-care. But we do have assistants. And then on the other side, it's assisted living, which they have nurses and nurse aides on that side of the building. But they don't do everything for them. They're just assisted.
Okay. Yeah, the place I worked at, let's see, it was a retirement home technically, right? So they recruited, people that were retired, right? Mainly with large estates because when they were called residents.
Mm-hmm.
I don't know if your customers or whatever are called residents or not, but anyway, they were called residents, and in order to live there, the resident had to sign their estate over so that the retirement home got their estate when they passed away.
We don't have to do that because our facility is completely self-paid. There's no insurance. So they have to pay it completely out of pocket, but they can keep all their possessions.
Oh, so the residents pay as like rent or something?
Yeah, it's basically rent. It's like living in an apartment.
Does anybody get evicted?
It has happened, and there's this really sad
Really?
story. This guy named Walt. He moved in his 60s, and he lived till like 109 or something, way longer than he had
He
expected
outlived
to.
his money.
He ran out of money, and after like living there for 40 years, they ended up kicking him out. It was so sad.
I was going to say, that's where I was going, because I would think they wouldn't do that.
They did. It was terrible.
Really? That would be terrible. Yeah, absolutely. Absolutely. So back to our problem, guys. Do you see that the probability that Brian chooses 6 stew and 6 stroganoff, or I'm sorry, 3 stew and 3 stroganoff, is simply this value divided by this value?
Yeah.
Do you see that? Does everybody see that? Does anybody not see that? Okay, let's roll the numbers. How do you tell 100-and-something-year-old guy that's lived there 40 years that, sorry, dude,
Yeah.
I wouldn't want, yeah.
I don't know if that was a GM decision or a corporate decision. Either way, I was not a fan.
No, I doubt anyone was. Anyone that has a heart. Anyone that breathes, right? Okay. Shoot. 15, 3, 10, 3, 25, 6. So what this equals, guys, is, or the way we do it, we're going to have 15 times 14. You can do this in Excel. You can do this on your calculator clearly. So go ahead and do it however you want. The way I do it, I'm totally old-fashioned. I understand that. Yeah. It's basically the setup. That cancels. Let's see what else we got. That. You end up with a bunch of prime numbers, right? So we have 25 times 23, 22, 7. And up here, we're going to have, that goes to 5, 7, 3, 4. So it's going to be 5 times 7 times 13 times 10 times 4 times 3 divided by this stuff. 25, 23, 22. Unless I screwed something up, which is totally possible, right, guys? Sevens cancel. So I get 13 times 6, which is 78 divided by 23 times 11. Is that anywhere near right?
I'm just trying to keep up with everything you're writing down.
Actually, it's exactly what I've written down in my notes. I forgot that I solved it. 253, right? Yep. No, because it's a combination, right? So it's 15 factorial divided by 3 factorial. Yeah, that's right. But also divided by 12 factorial. N minus k. 15 minus 3 goes downstairs. That's why 15 factorial over 12 factorial is simply 15 times 14 times 13. So that's how I got this. And that's also how I got this up here. And then you're just dividing by 3 factorial in each case, which is, of course, 6. But like I said, a lot of stuff cancels.
Is doing these like by hand the way you did it, like usually the best way?
Oh, well, most students would tell me that I'm crazy. Seriously, they would. But I still remember all my multiplication tables that Miss DeGangi in fourth grade. Fourth grade basically abused us with.
I had to do.
We had to do numbers 2 through 12, right? So there were 10 rows. Skip 10 because 10's trivial, and then you have 2 through 12. Now these were randomized, so they didn't go in order. You just Mr. Ganji just rattled off these numbers for the rows and rattled them off for the columns. Okay, all right, and you had to multiply. So you had 100 products to fill out, right? 10 by 10, right?
Mm-hmm.
Times 4. There were 4 of these things. She called them cages. Okay, and you had to solve. You had to solve 4 of these cage things in 4 minutes.
Gross.
Yeah. Once you did that, once you're able to solve 4 in 4 minutes, you didn't have to do them anymore. Well, most of us ended up having to do them every single day for the entire school year. I ended up being able to get out of it maybe in March-ish. But that's I considered it abuse. Okay, total abuse. I still do, in fact. But that's how I know the times.
Yeah, drilled it in.
Drilled is one word for it. Yeah.
Is there a better?
I'm sorry.
Do you have a preferred word? Over drilled.
Maybe over drilled or ingrained on my DNA involuntarily. I don't know. In spite of her draconian measures, and by today's, actually, I think she probably would be charged with child abuse by today's standards, and that's probably not too much of an overstatement or an exaggeration. But anyway, yeah, trust me, I wasn't thinking along those lines. Anyway, guys, we figured it out, didn't we? Do you want to do another example?
Yeah.
Okay. I got to think of one. Actually, maybe we can draw one from the textbook. Maybe they got a decent one in there. Yes. Yep. I'm trying to find a good example, guys. I'm not seeing one. Well, here, let's just start doing them in the. Well, here, we can do a similar one. Okay. Can I get rid of this? Talk to me.
Yeah.
Okay. Now, let's see. Who else has a job that we can pick on? Just make something up. No one? No one, really. All of you guys have always been unemployed. I find that hard to believe. Okay, cool.
I think it's a cool job.
Sure. Yes, no? Okay. So you create CAD designs for jewelry, right? So is each one custom? In other words, if you create a CAD design for guys, I'm a complete Neanderthal when it comes to jewelry, so I really don't know. A micrometer. Okay. He has to create CAD designs for. So, like, did you do like the things that are on necklaces? Okay, well, today it's stuff on necklaces, but I don't know what it's called. What is the thing that's on a necklace? It's not a pendant, is it?
That'd be a pendant, right?
I don't know. The thing on the chain. What's that called?
Or a charm?
Okay, necklace charms. He has to create CAD designs for necklace charms and bracelet. Don't bracelets have these little things that hang off them? Can we just say earrings? Can we just say earrings? Would that work? Guys, I am totally out of my element here. Okay, so in a given week, we're going to assume that it takes you the same amount of time to do, to get the measurements for a necklace charm and earrings. Okay, we're going to, right now, it's just for the problem. Takes the same amount of time. So in a week, Esteban can do maybe 2 a day. Is that fair, or can you crank them out faster than that? Okay, okay, fine. 2 a day. Can do 10 CAD drawings, right? For 10 of the 10 of these things, okay? Now he picks his boss picks his uncle, you said? Is okay. In case you're wondering, I'm trying to create the problem on the fly. So in a week you do 10. So you're gonna grab 10. There are how many necklace charms and how many earrings do you have to like pick from or whatever? Because it's gonna. Okay, but you have a lot more to choose from. You can't possibly. What I'm getting at is you're going to pick a few necklaces, you're going to pick a few earrings out of a much larger pile. Well, wrong way. There's 17 necklace charms to pick from. Let's make it 18, make the math easy. So 18 necklace charms. And how many earrings? Probably a lot of earrings, huh? So yeah, let's make it only a few. For 15 earrings. No, 15. Let's make it 12 earrings. Total, okay? So Esteban he's got this box of 30 total, right? To pick from, and he grabs 10 of them. What's the probability that, give me a number. How many are necklace charms? How many of the 10? 4. So if 4 are necklace charms, how many are earrings, guys? Thank you. Okay. Probability 4 necklace charms is what? Well, this is the probability, right? Probability that you have 4 necklace charms, right? No. It's the number of ways for 4 necklace charms, right? Times the number of ways, multiplicative rule again, right? Number of ways for 6 earrings, yes, no? Guys? Divided by the total number of ways, which is 30, taken how many at a time? 10, right? Right?
Yeah.
Okay, let's do it. So we got 18 times 17 times, and guys, again, you can do this on your calculators. You can do it in Excel. Whole bunch of different ways to do it. That's the number of ways to pick 4 necklaces out of 18. Then we have 6 earrings out of 12, right? Oh, this is going to get nasty. Sorry, guys.
And you came up with that on the fly.
I did. Divided by 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, we can get rid of this right off the bat. Not sure how much it helps us, but we can. Let's see. That's going to go to 8. That's going to go to 6. What do we have? So we have nothing downstairs, so this is going to actually fold upstairs. Oh, yuck. Divided by... Oh, this is just nasty, guys. Yeah, we're gonna... It's not gonna work. So let's see, we can do this. 3, right? 29 stays. But this we can do, that becomes a 4. Then we're left at, this becomes a 3. And we got an 8, right? This becomes a 12. That goes away, that goes away. It's not as bad. Let's see, can we do anything simple? This is 25, so that becomes a 5, that becomes a 2, right? This is 15, so that goes away. We got a 12 and a 12. That works. We got a 11 times 2 on a 22. That works. I guess it's getting there, right? We got a 3 and a 3. That goes away, right? What else? What else? What else? We got a 21 and a 7. So this becomes a 3. And then that becomes a 2. And this goes away completely. And we got this. That goes away. So we got that. So we're left with 29 times 13 times 23 downstairs. Oh, times 3. I forgot about this one. This 3 goes away if we do that. Okay. So downstairs we got 29 times 13 times 23. Is that right? Upstairs we got 17 times 8 times 3. I have no idea if that's right. Anyone got an answer?
Let me plug that in real quick.
Yeah.
I got 0.047. Google doesn't give you fractions.
Oh, really?
Yeah.
So if you do the division,
Fraction, it's 408 over 8,671.
408 over what?
8,671.
Is that what you get by any chance?
Yeah.
Really?
Mm-hmm.
I'm shocked that I was right. Okay. So there's a 4.7, about a 5% chance. Okay.
When I plugged it into my calculator, I actually got double that answer. I ended up getting 816 over 8,671.
Huh. Okay, it's one of the other guys.
Well, I just plugged in what you had at the bottom. I didn't plug in the whole thing.
So I'm probably wrong. I'm probably off by a factor of 2. I would be more willing to accept that than, that I'm right and you guys are wrong. So somewhere I dropped a 2, right?
Yeah, that makes
Tell
sense.
you what, there's another way to do it, or to check it. Did anyone figure out? Well, you know what? Let's move on. Do you guys get the idea?
Yeah.
Let's see if we can set up a euchre. Well, we can do poker, I guess. You want to do a poker hand?
Sure.
And I'm doing this on the fly, so. Oh, I got one. How about if we do a blackjack? How about if we do 21? Without, just getting 2 cards totaling 21, without any. Okay. Get 2 cards totaling 21, right? Yes, no? That's the object of the ball game, right?
Yeah.
So, 10s, right? Queens, kings, total up They're worth 10 points or whatever blackjack calls them. I can't remember. Right?
Yeah. Tens and
Aces, in this case, are 11. Well, they're 11 or 1, right? But if we're going to get 2 cards totaling 21, clearly we need the ace to be worth 11 and one of these kinds of cards, right?
Mm-hmm.
What's the probability of 21? Now we're going to have a 52 card deck, right? Yes, now?
Yeah.
In case you are not a card person, there's 52 cards in a deck of cards. There's no jokers. We're not doing that. Okay. There are 4 each of ace, 2, 3, all the way up to 10, jack, queen, king. Okay. So if you do the math, there's 13 numbers, right? Ace through king. So there's 13 cards, and there's 4 of each of them. Okay. And those are the suits, right? Which for blackjack really doesn't matter, at least for this problem, right? And the suits are what? Clubs, hearts, diamonds. Diamonds are forever. And what? Spades, right?
Yeah.
And in case you're wondering, oh boy, the symbols, what the club looks like.
That's like the clover.
That's like the 3-leaf clover. Yes, now?
Yeah.
I taught this
good.
course one semester, and several students didn't have any knowledge of cards. The standard, that's the spade, isn't it?
Yeah.
And then those are the black suits, right? The heart looks like a heart, right? The little point. And and by the way, it's red, right? And the diamonds, believe it or not, look like a diamond. Okay, so in case you're wondering, those are the 4 suits, okay? That's how we get 52 cards, guys. 13 of each suit times 4 suits. That's 52 cards, okay? Now, in blackjack, everybody starts off getting 2 cards in the beginning, right? That's how blackjack is played. So, how do you get 21? Probability of a 21 is equal to the number of ways to get 21, right? Divided by the total number of ways for 2 cards, right? Yes, no?
Yes.
This goes back to our definition of probability. Anyone got a 5-minute warning for me? Hey, this thing actually works. I didn't know that. I get 507. Is that right? Is it close?
Yeah.
Yeah.
Oh, 505 on my computer. Okay. All right. So, ready to roll, guys? How many ways are there to get 21?
So would that be number of ways to get a 10 times number of ways to get an ace?
Yeah. Right?
Like 10 points, not a 10 card.
Right. So there's 4 times 4, right? 16 total cards that equal 10, yes, now?
Yes.
And there's 4 total cards that equal 11. Right? So, this is what we need. Okay? Let's see, what's the best way of doing this? Right?
Yeah.
Times. The second one's 51 because we have one less card to choose from.
Oh. I wouldn't have thought of that.
Am I doing something doesn't seem right? No, this is right. Yeah, this is right. 50, I think. Go ahead and do the math. I'm going to check something real quick because something doesn't sit right with me.
Wouldn't it be 16 over 1 and 4 over 1 because you have 16 possible 10 cards and you're trying to get one of them, and then you have 4 possible
That
aces?
seems like a better approach. It really does. It really does.
What is he suggesting?
Go ahead and whoever said that.
So what I'm suggesting is, like in the previous examples we did, we would do the total number of that option and then how many we need of it. So instead of doing 52 over and 16, I'm saying we should do 16 and 1 because you need one of those cards and there's 16 of them available. And then there's 4 aces available and you only need one of those. So that would be 4 over 1. So that is what you plug in instead of the 52, 16, and the 51, 4.
So the way we have it right now, it's yeah.
Okay. Yeah. 16, 1. Four, 1, right? Number of ways to draw 10, card worth 10 out of 16. Number of ways to draw 1 card, 1 ace out of a total of 4. Okay. There are 52 times 51 ways to draw 2 cards out of a 52 card deck. Do you agree? Does everybody agree with the denominator at least?
Would it be 20 out of 2? Like 20 over 2? That there's 20 possible cards that equal 21 together?
But we don't want
there
any
are,
of 220.
but if you do that, then it's possible that you would pick 2 10s, right? You need to break it up like this. Instead of you're suggesting this way, right? Upstairs.
Oh, total ways for 2 cards, not just Okay, I see what you mean.
Yeah. So, guys, there's only one way to draw 110 out of a total of 16 that are available. There's only There's only 16 ways to do that, I should say. There's only 4 ways to do that. To do the ace. Downstairs, we have 52 times 51. Some of the simple math is this, and this is really what we're left with. 16 over 13 times 51, what do you get?
I got 16 over 663.
And that's going to be about what, 2.5%? Something like that?
Yep. 0.024.
So there's approximately 1 in 40 chance that you're going to hit blackjack. Okay? With just 2 cards. All right. Okay. Any questions on? Now we have to move to, or we're going to move to, a different, couple of different terminologies and definitions. Okay. I want to make sure that I set the problem up correctly, or the situation, I guess. So just bear with me. I want to make sure I get it right. Because if I screw one little thing up, oh, come on. Where is that example? Oh, it's a good one too. I wonder if things got really jumbled in my notes, which is not good. Well, it's just things, that's all. I know the event A is, it should be right here. The event A is that we roll a 1, 2, or 3. This is really irritating. I can picture the page in my head. But I can't find it. And I know I'm going to get one stupid thing wrong. It's going to blow everything out of the water. It shouldn't be in here. Where? So A is we get a 1, 2, or 3. B is 1, 3, 5. And the event C is 1, 2, 3, 4, 4. Oh, no, that's not it. Thought that was it.
5-minute warning.
Thank you. It's going to take me 5 minutes to find the stupid.
Just getting 4-minute warning.
What's that?
I said actually 4-minute warning.
All right. Well, we're going to set it up, and hopefully I remember the events correctly. I think I do. But if I don't, then that's gonna. So B is the event that we get a 1, 3, or 5. C is the event that we get a 1, 2, 3, or 4. Okay. Actually, you know what? Let's talk about conditional probability first. That'll also give me time between now and Thursday to work on this example. Forget I said this. Let's talk conditional first. Okay, conditional probability, and we're just gonna say a couple things, and then I'm gonna give you a lot of situations where we have conditional probability. Okay. Frequently, two events are related such that there's a symbol for that, but my digital logic guys couldn't remember what such that was anyway. Such that the occurrence, does occurrence have 2 R's in it?
I don't know.
I don't remember. The occurrence of one event affects the probability of another. There are, I'm going to let you get this down, of the other. Example, there are literally millions of examples. Okay. As an example, let A be the event that it's January in Ohio. Let B the event that that it snows. On a particular day. Does the event A, meaning that we're in the month of January in Ohio, if we know that, does that affect the probability of B?
Yes.
That it snows? Right? What if C was that it's June in Ohio? Does C affect the probability of B?
Also, yes.
It does. It does. It's just the opposite way, right? What about if we're talking sports, right? The baseball season just ended and the playoffs are beginning. The event D is that the Rays are playing at home, playing a game at home. And the event E is that the Rays win. Does the fact that the Rays are playing at home, does that affect, it's not a guarantee, but does it affect the probability that they're going to win? Well, if you follow sports, right, you stand a better chance of winning at home than you do on the road, right? Playing at the other guy's ballpark, right? What about this? The event C is that the day of the week is Tuesday. Well, here let's go into the event G. Is that it's Tuesday. H is the event that it rains, and not I, but J is the event that we have you have school today, class today. Does the event G, if we know that it's a Tuesday, G has occurred, does that affect the probability that you're going to have class today? Well, if you have Tuesday class, absolutely, right?
Mm-hmm.
Right? I mean, it's not a guarantee, right? Maybe it's a semester where you don't have any Tuesday classes, but in general, yeah, it's gonna affect the probability, right? What about the probability that it rains on the particular day? Does it rain on Tuesday any more than not? Does that tell you anything?
Not really related.
They're not related at all, right? So sometimes events affect one another, right? Sometimes they don't.
Mm-hmm.
We'll pick it up here on Thursday. Okay, guys? Are there any questions? Well, not necessarily a feedback loop, but we have that situation here, don't we, Esteban? If we know that A has occurred, then that affects the probability of B, definitely. Right? Whereas if we know that B has occurred, that also affects the probability that A is also occurring. Right? And we're going to see that if this is called conditional probability. If one event is conditional on another, the opposite is also true.
Huh.
Whereas up here, we know that the event H is not conditional on G, right? So therefore, we know that we also know that if it rains, that we don't know anything more about G. So G is not conditional on H. H is not conditional on G. So it is a two-way street, as you were alluding to. No, it's just the way conditional works. And when we define conditional probability, you'll see why. Okay?
All right.
Any questions, guys? Good class. Very good class. Just what do you guys think? Would just the date of the lecture be a good enough title for the video?
Yeah, just like statistics 10-5 or something.
That's frequently what's done in other classes. They just go by dates. All right, guys.
It also helps. I don't know if you want to go through the effort, but if you put them all in the playlist and then link to the playlist, and then we could have them all at one click.
There you go. All right. I gotta go, guys. Nice calling me.
All right.
Have
Have a
fun,
good
guys.
one.
Take care. Bye bye.